Welcome to another session of Circuits and Networks. And today we are going to take class 10, that is problems and solutions on single phase applied to series RLC circuit. So in our past classes from class 1 to 9, that is under single phase AC circuits, we have seen RL, RC and RLC, the theory as well as the numericals, problems and solutions. And today we are going to end up especially the problem which was involved with series RLC circuit when they are applied across single phase input voltage. So from our past class, we have come to a conclusion that the power factor, it is derived either from voltage triangle or impedance triangle or power triangle. So this is the formula to obtain the power factor. Once the power factor is obtained, it is easy for us to determine the real power, the reactive power and the apparent power for the given RLC parameters applied to single phase AC input. So let us start with the basic problem. An RLC series circuit having 10 ohms, 0.02 henries, 20 microfarads respectively is applied across 240 volts, 50 hertz input supply. We have to estimate the power drawn by the circuit. So first take the data as it is. You have input voltage as 240 and 50 hertz. Then a current is assumed to flow. The parameters of RLC series circuit, it is given as 10 ohms, 0.02 henries and 20 microfarads. Now XL, which is known as the inductive reactance, is given by 2 pi FL. Just substitute the value of F as 50, L as 0.02. We are going to obtain the inductive reactance in 6.28 ohms. So this is in ohms because it is inductive reactance. That is why the unit is in ohms. Similarly, you can estimate the capacitive reactance whose formula is given by 1 by omega C. Omega is 2 pi F. Just substitute the value of F and C from the given problem. So here 20 microfarads, micro indicates 10 to the power of minus 6. This goes to the numerator and becomes 10 to the power of 6. So 10 power 6 divided by this denominator parameter will give you the value of capacitive reactance to be 159.15 ohms. Now once we obtain the value of R and reactive components, this will give you the value of total impedance. The total impedance is equal to R plus J, XL minus XC. Just substitute the value of XL and XC, which is 6.28 minus 159.15. This will give you the value of Z as 10 minus 152.87 J ohms. So this particular value is in rectangular form. So this form can be changed to polar form with the help of your calculators, or you can do mathematically by taking the modulus of Z, which is equal to under root of 10 square plus 152.87 square. Under root of this value will give you the value as 153.19 as the amplitude value, and angle value you can get as tan inverse of y by x. Y is here 152.87 divided by 10. So this is how you are going to get the value. Now in this particular case, you can see 153.19 at an angle minus 1.505 ohms. Either this is in this form or you can take in this form, 153.19 at an angle minus 86.25. What is the difference? The above value is in radians, the below value is in degrees. So it depends upon your calculator, how your calculator you are using. Just switch on your calculator and make sure it is running under degree mode, and then you substitute the values. You're going to get the answer in degrees. Under radians, you're going to get this value. And since we are dealing with the power factor, we require the answer in degrees. That's why we are considering in degrees. So mathematical formula to convert radians into degrees is this. That is, degrees is equal to radians, the value, into 180 by pi. Pi value is 3.14. Just substitute the value, you're going to get the values in degrees. So this you can cross check from your calculator. Okay, once we obtain the value of impedance in polar form, I can easily obtain the phase difference, which is nothing but 86.25. The phase difference is the angle with which the voltage and current lead or lag with each other. So here it is 86.25. So calculate the series circuit current, which is I is equal to V by Z. So V is 240, it is given in the problem, and Z is obtained to be 153.19 in magnitude form. So the value of current is 1.56 amperes. Once we obtain the value of current, we can calculate the power factor, which is equal to cos phi. Phi is the phase difference. So it is 86.25, which is equal to 0.065. So this is the value of power factor. Now once the power factor is obtained, you can calculate the power drawn by the circuit, which is equal to Vi cos phi. Just substitute the value of Vi and cos phi. You're going to get the value as 24.3 watts. Now this is the real power of the circuit. So inductive and capacitive nature will also give you the reactance power, which is given by Q, which is equal to Vi sin phi. So Vi sin phi, substitute the value of V into I, and sin phi is nothing but sine of 86.25, which is going to be obtained as 0.997. So this will give you the value of reactive power to be 373.27 volt ampere rating. Volt ampere rating is the unit of reactive power. And what would be the apparent power? Apparent power is given by S, which is equal to V into I. Just multiply 240 into 1.56, you are going to get the value of apparent power. So this is how you solve problem for single phase RLC circuit applied to single phase input. Another problem, 250 volts 50 hertz supply is connected to series combination of Z1 and Z2. They are in polar form. We have to calculate the current and the power factor powered on by the series combination. So this is the representation of this particular statement. The values of impedances are given like this in polar form. Just add the two values. So I'm going to get either in rectangular form or in polar form the total impedance value like this. So once I'm going to obtain the magnitude, and current can be estimated with the help of this, which is nothing but 250 by 53.86, which will give you the value of current as 4.64 amperes. And the phase difference is 42.29. So cos phi, which is power factor, which is equal to cos 42.29, which is equal to 0.739. Once we obtain the value of power factor, we can easily get the value of power, that is the real power, Vi cos phi. Just substitute the values, 250 into 4.64 into the cos phi value, which will give you as 857.24 watts. So this is the value of power drawn by the series combination of the circuit. In another problem, the voltage is given as 240 50 hertz. The series circuit is applied across this, and the voltage measured across inductor, across this parameter, is 360. Across resistor, it is 108 respectively. Okay. If the circuit draws a leading current of 12 amperes, so the circuit is drawing the leading current, then determine the values of RLC parameters. So we have to find out what is R, L, and C individually, and the voltage drawn by the capacitor. Okay. Just take the inputs. These inputs values are given from the problem. The inductor voltage measure is 360. The resistance voltage is 108. The current is 12 amperes. Input voltage is 240. Frequency is 50. Okay. So R is obtained according to Ohm's law. R equal to the ratio of voltage by the current. So the voltage across resistance is 108 divided by 12. Since the series circuit, same current flows in RLC, so same current 12, which will give you the value of resistance as 9 ohms. XL is equal to VL by I, because VL is equal to I into XL. So substitute the values, that is given as 360 divided by 12, which is equal to 30 ohms. And impedance of this circuit is given by V by I. So 240 by 12, which is equal to 20 ohms. So this you can see the total impedance of the circuit is obtained to be 20 ohms. Okay. We know that Z is equal to R plus JX, and when inductor is dominating, the formula is JXL minus XC. But here it is stated that the current drawn is leading. Since the current drawn is leading, I have to change this formula as R minus this XC I'm taking here and XL I'm taking here. So minus common, XC minus XL. And we need to find out the voltage drawn by the capacitor. So the unknown parameter is XC over here. So this is we have to obtain. So when you're taking the magnitude form, modulus of z is equal to under root of r square plus xc minus xl whole square. I hope you understood this formula. With this, squaring on both sides, so you have z equal to 20, r equal to 9, and xl is equal to 30. So squaring on these both terms, I'm going to get xc minus 30 is equal to under root of 20 square is 400, 9 square is 81. So 400 minus 81 under root values is equal to this. So it is root of 319, whose value will be obtained as 17.86. Now we require xc, so xc is equal to 17.86 plus 30 will give you the value as 47.86 ohms. So this is the value of xc. Once we obtain the value of xc, we can calculate the voltage developed across the capacitor, which is equal to 12 into 47.86, which will be obtained as 570.72 volts. So this is the voltage developed across capacitor. Now once the formula for x is obtained, you can get the value of capacitor also. C is equal to 1 by under root of 1 by 2 pi xc, just xc is taken here. So substitute the value of xc, that is 47.86, which will be obtained value of C is equal to 66.5 microfarads. So this is how you calculate the capacitance, inductor and resistance for the given problem. What else we can find? We can also find out the inductor value. Inductor is nothing but XL is 30, and we need to find out L. L is equal to 30 divided by 100 pi. 50 into 2 will become 100 pi, which will give you the value 0.942 henries. So R is 9, R is 9, L is 0.942, and C is 66.5 microfarads. So these are the RLC parameters. You can also calculate the power factor, which is nothing but R by Z from impedance triangle. Just substitute the value of R and Z. You're going to get the value of power factor as 0.45. So this is how we calculate the individual RLC parameters when voltages are measured across them. So according to the given problem, we have to select the data and just substitute in the formulas and obtain the unknown parameters from known parameters. So in today's class, we have dealt with the problems on single phase AC circuits. I hope you like this video, and please subscribe my channel and press the bell icon for the future notifications. Thank you.